Good morning, my name is Francesco Maura from University of Miami, and I'm here attending American Society of Hematology 2024 annual meeting in San Diego. Whole genome sequencing right now, it's very complicated to do in clinic for several reasons, but the most important is infrastructure. Most of the cancer centers in the United States and definitely all, if not virtually all cancer centers in the world are not equipped for this type of test. However, whole genome sequencing and its cost are dropping. So 10 years ago, whole genome sequencing cost thousands of dollars. Right now, cost few hundreds. And because the new International Myeloma Society guidelines require a sequencing testing now for defining high risk, there is a new high-risk myeloma definition that requires TP53 mutations to be included, which means that every center in a world that wants to define high-risk myeloma and treat them differently, they will have to do targeted sequencing. And so if you don't do targeted sequencing, you will not be able to treat your patient and profile your patient properly. And so the decision about how to sequence this patient's DNA can be done with the simple panel or with whole genome sequencing. Because of the cost and the quick development of the infrastructure across different cancer centers and the diagnostic providers, I do believe that in the next 3-5 years, most of the patients with multiple myeloma, if not all patients in the United States, will have some sort of DNA profiling. Hopefully whole genome sequencing, that in my opinion is the best and most informative technology. Right now, most of the diagnostic in multiple myeloma, if not all, is performed with FISH. So FISH is a kind of like a steam engine technology compared to next generation sequencing that is our electric car. So we're still using for every patient this very old technology, which is good. We can detect these alterations very well, but we can only detect those alterations, and it's also very expensive. So the advantage of doing next generation sequencing is that you can detect the same information that you do with FISH with only one test, so not with multiple tests, one for each alteration, but with one test you get all of them, and you can detect more information. You can detect alterations that we cannot detect, or new genomic features, or TP53 mutations that is currently not detected by FISH. So I think next generation sequencing not only offers a logistical opportunity, one test instead of many, but also offers a resolutions that allow us to better understand cancer and eventually also identify new markers that we still don't know. As every new technology, it starts development phase that is very expensive, everything costs a lot, and then over time we optimize our product, we optimize the efficiency, and the price drop. In the recent years, in the last 2 years, different companies developed what we call low-cost genome sequencing that, thanks to specific chemistry and methods, drop significantly the cost from few thousands to few hundreds. So is going to open the gate for a major revolution in cancer, because the test right now is less expensive than most of the other tests, and it's incredibly more informative. As I said before, we are talking about an electric car with autopilot versus a steam engine car of the 19th century. So it's really like we are at the beginning of a resolution, and I think how to handle all this amount and wealth of data will be one of the priority for the multiple myeloma community.